We're going to be talking about 2.3 on page 43 of your notes packet. So if you need to pause and open your notes packet at the same page so that you're ready to take notes, go ahead and do so. Great. We're going to be talking about long division of polynomials and synthetic division of polynomials. So let's get started. If we're given polynomial f such that x equals a is a 0 of f, that tells us, that implies, that x minus a is a factor of f. What does this really mean? If I have f of x is equal to, let's say, x minus 3 times x plus 2, I know that both x minus 3 and x plus 2 are factors of my polynomial. That tells us, right, that if I set it equal to 0, I would get x equals positive 3 and negative 2. So those are my zeros of my polynomial function, all right? As we continue, let's go ahead and scroll down and look at the division algorithm, all right? So there's a lot going on here. So before we kind of jump in, I want you to think about doing the long division problem. 6 goes into 13 how many times? So 6 goes into 13 twice. 2 times 6 is 12. Subtract, we have 1 left over, so plus 1 sixth. Or we could have plus our remainder, right? Like back in the day, you would write 2r6. We won't be using the r, we'll be using the fraction, all right? So let's kind of put this back into more mathy terms. So if we have our polynomials f of x and d of x such that d of x is not equal to 0, and the degree of d of x is less than or equal to the degree of f of x, that tells us that we have unique polynomials q of x and r of x such that f of x are dividend. So here in this problem, 13 was our dividend, is equal to our divisor, all right, that's 6 in this problem, times the quotient, that's 2 in this problem, all right, plus the remainder, the 1/6, right? That makes sense. So now let's go ahead, get rid of this, and look at some polynomial long division. So if we scroll back up to example 1, right, when I set this up, I have x minus 3 going into x cubed minus 2x squared. Notice how there's no x term, there's no linear term. I'm going to need a placeholder. This is super important. So plus 0x minus 9, right? So the way that we're going to do this is we divide, multiply, subtract, bring it down, and then we bring it on back, all right? So step 1, we have x cubed divided by x gets me x squared, and I'm going to line it up above my x squared term here. Then I multiply, so I'm distributing my x squared to my x and to my negative 3. So when I do this, I get x cubed minus 3x squared. Then from here, now I have to subtract. I like to do this in a different color, and I have to distribute, so that makes this a positive. Then I'm going to add down, so those cancel, and I get x squared. Then I bring down my plus 0x, and now I'm going to do it all over. So x squared divided by x, so x squared divided by x gets me a positive x, and then I'm going to multiply. So I'm now going to distribute my x to both my x and my x minus 3. So when I do that, I get x squared minus 3x. Then I have to subtract again. Don't forget to distribute the negative, making the 3x positive. So now I have 3x because these canceled. And then I bring down my negative 9. And then I'm going to divide again. So now I have 3x divided by x is just 3, so plus 3. Then I'm going to distribute my 3x to the x and to the negative 3. When I do that, I get 3x minus 9. Oh, look, how convenient. They're going to cancel. When I distribute the negative, they both cancel, giving me a remainder of 0. So this means that x minus 3 times x squared plus x plus 3 is equal to x cubed minus 2x squared minus 9. Right? That is how polynomial long division works. Let's go ahead and look at another example. If you need to pause and rewind or rewatch, please feel free to do so. All right, so now let's look at example 2. We're going to need a lot of placeholders when we do this one. So I have x plus 1 goes into x to the 4th plus 0x cubed, you need a placeholder, plus 0x squared, another placeholder, plus 0x, and then minus 1. So divide, multiply, subtract, bring it down, bring it on back. All right, so x to the fourth divided by x gets me x cubed. Then I'm going to distribute x cubed to my x plus 1. So I get x to the fourth plus x cubed. Then I have to subtract. So these cancel, and I get negative x cubed. Bring down my plus 0x squared. Now I'm going to divide. Negative x cubed divided by negative x is negative x squared. Now I'm going to multiply. Negative x squared times x plus 1. So I get negative x cubed minus x squared. Now I'm going to distribute a negative, making both of these positive. These cancel, and I get x squared. And now I'm going to bring down my plus 0x. All right. And then I'm going to divide. X squared by x is x. Then I have to distribute. So I get x squared plus x. Then I have to subtract. Don't forget to distribute the negative to both terms. These cancel. Negative x. Bring down the negative 1. Negative x divided by x is negative 1. Distribute. I get negative x, negative 1. Oh, look. When I distribute my negative, they're going to cancel because they're both going to become positive, and I have a remainder of 0. So what this means, right, is that my divisor, which was x plus 1 here, all right, times my quotient, which is the answer left over when we divided, is equal to my dividend, what was being divided. That is how the structure of these problems works. All right, now let's go ahead and look at the next page. All right, go ahead and pause the video and do this one by yourself. Great, then we can come back and let's see. All right, so the only way that this one is a little bit different is that our remainder is not, in fact, 0. We have a remainder of negative 6. So you have two choices. You can either do minus and then 6 over our 3x plus 1, or you can put plus and then assign the negative to the 6 in the numerator. It's kind of personal preference here. I don't have a strong feeling either way. All right. Now let's go ahead and look at another way that I think is actually way more efficient than long division, all right, which is synthetic division. So synthetic division, all right, so if we have our polynomial ax cubed plus bx squared plus cx plus d, and if we're dividing by the factor x minus k, we're going to use this following pattern, right? So let's kind of zoom in here so we can see, all right? Notice we took each of our coefficients here, all right, and that's what we have going in descending order. They're the coefficients of our dividend, what we're dividing into, all right? Then notice here I have k. That's the 0 associated with the factor that we're dividing by, okay? And so what we do here is we bring down the first coefficient, and then we multiply a times k, that's what goes here, and then we add down. And then we do it again. Then we multiply this by k, that's what goes here, add down, repeat. This last term right here is our remainder, okay? Our vertical pattern, add terms, diagonal pattern, multiply by k, that's 0 of the factor, all right? The big thing here is that this only works for divisors of the form x minus k, where the degree of the divisor is 1. So if I had asked you to divide by, let's say, x cubed minus 3, it's a binomial, sure, but our degree here is 3, so you cannot use synthetic. You would have to use long division. So now let's do a couple of examples. So first we have x plus 2 is our factor. That implies that x equals negative 2 is our 0. So we're going to have negative 2, and then I'm going to list my coefficients going in descending order. If I skipped a term, I would need a 0 as a placeholder. So I have 5, 8, negative 1, and 6. So step 1, bring the 5 down, then multiply 5 times negative 2, negative 10. Then I add vertically, negative 2. Negative 2 times negative 2, positive 4. Negative 1 plus 4, 3. 3 times negative 2, negative 6, add down. 6 minus 6, 0. So we have a remainder of 0, which means that x plus 2 is indeed a factor of our polynomial, all right? And the way that we write our answer, this is going to be the constant. This is going to be the linear term coefficient, and this is going to be the quadratic. So all we're doing here is we're going in increasing degree order. So we have 5x squared minus 2x plus 3, all right? And that times our factor x plus 2 is equal to our whole polynomial, which I could write out, but we'll save some time and not, all right? So now let's look at the next example, extra practice example 4. So to use synthetic division here, step 1, if x minus 2 is my factor, then go ahead and we know that 2 is going to be our 0 that we're dividing by. So I have now my list of coefficients: 2, negative 8, 13, negative 10. First step, bring down the 2. 2 times 2 is 4. Great. Add down, I get negative 4. Multiply, I get negative 8. Add down, I get 5. 5 times 2, positive 10. Add down, I get a remainder of 0. And so now I have 2x squared minus 4x plus 5. That's the quotient when I divided my polynomial by my factor, x minus 2. Now let's continue on to the next page. We have a couple of more theorems that we need to talk about and just 2 more examples. So the remainder theorem tells us that if we have a polynomial f of x divided by the factor x minus k, the remainder is equal to f of k. Okay, so if we use that rule over here with example 5, it says use the remainder theorem to find each function value. So this means that I can use synthetic division with negative 1 into 4, 10, negative 3, and negative 8. Bring down the 4, negative 4, 6, negative 6, negative 9, positive 9, 1. So now I don't have a remainder of 0, I have a remainder of 1. And what this tells us is that f of negative 1 is equal to 1. You can also check this by using function composition and just plugging into our function at the top of the page. So if I had 4 times negative 1 cubed plus 10 times negative 1 squared minus 3 times negative 1 minus 8, now I would have negative 4 plus 10 plus 3 minus 8. So I'd get 6 plus 3 minus 8, 9 minus 8, which is 1, which is exactly what we found when we did our synthetic division. So both ways work, so it's nice that you can check your work here. All right, the other theorem that we need to talk about is our factor theorem, right? It tells us that a polynomial x has a factor, x minus k, if and only if f of k is equal to 0. So let's use this to go ahead and do the next example. All right, so now we have example 6, right? It says x plus 3 is a factor, so we're going to use synthetic division. If x plus 3 is the factor, negative 3 is the 0. So I have 1. I need a placeholder here for my x squared term, negative 19, negative 30. Okay, and so I bring down the 1, negative 3, 9, negative 10, positive 30, 0. So because my remainder is 0, I know that x squared minus 3x minus 10 is a factor of my polynomial. And the direction said find the remaining factors of f of x. So if I have that times my first factor, what I divided by, f plus 3, I can now further factor this polynomial. And when I do that, I get x minus 5 times x plus 2 times x plus 3 is equal to f of x. This is really useful because if we take this back to the lesson last week where we were graphing polynomials and talking about behavior of the curve at the zeros, I could now sketch my polynomial. I know that I have a 0 at 5, at negative 2, and at negative 3. I know that it's going to pass straight through each of them because none of them have a multiplicity that's even. And then if I come up here and if I look at my function, I know that the leading coefficient is positive and that the degree is odd, which means my end behavior is as follows. So it's going to look something like this. certainly not a perfect sketch, but that can kind of give you a picture of why being able to factor using synthetic or long division is a useful skill. Please let me know if you have any questions, and I will see you on Zoom. Have a good day.